Thank you very much, Sarah. I'm delighted to be here this morning on behalf of the ACEI and of our members. I'm very pleased to be invited here as part of the CETA series of presentations and in hosting today's event. We hope to give you some context of an Irish perspective in relation to where things are at in the world of BIM. My apologies, I've leaned on the mouse here and my slides have gone a little bit forward. As Sarah introduced me, my name is Ciaran Kennedy, President of the ACEI and Managing Director of Barra Mahoney Consulting Engineers. And as a member of the ACEI, we're involved in the Structures Committee, and we've got a very active BIM committee in the ACEI, which covers all disciplines across the built environment. I'm sure that people who have attended these events before have met several of our colleagues who have been involved in the presentation of previous CETA presentations, particularly Brian Hiff has been heavily involved and would be a common name and face that you would have met at these previous functions. There's lots of cross-pollination between the BIM committee, both with Engineers Ireland and the ACEI and our counterparts in other organisations. In addition to the work of the BIM committee, the Structures Committee also has a dedicated Structures BIM task force, which has been set up to review the work of those involved in BIM. Needless to say that the members of the Structures Committee tend to be the managing directors and directors of different organisations, and it was only thought proper that their counterparts who are more at the cutting edge of BIM and the implementation of standards have a voice at the table. And for this reason, a particular task force was set up, and it's been very interesting to see the debate that this has brought about and to get the feedback from people that are using BIM on a day-to-day basis and being able to feed that back into our board meetings. In our own organisation, we have a very well developed BIM capacity. We started the implementation of BIM probably in earnest, it's probably fair to say, about 6 years ago. We had dabbled with it before that, but it's built up over the last 6 years or so to a more a stronger and certainly far more integrated design tool. And at present, with a staff of approximately 90 members, we'd have 20 people or so that are well tooled up and using BIM capability on a day-to-day basis. This is a composite image just of a couple of our projects that we've done over the last while, just pieced together just to show the scale of work that we've been involved with on the BIM stage. At present, a significant number of our projects would utilise BIM at different levels of applicability. And I think that's really where things are at, trying to determine the level of applicability and the level of, not only level of detail, but the execution standards that need to be adhered to. The implementation, in our opinion, of BIM, of full and proper BIM, is probably behind where we'd all like to see it being at. And I think this has been a topic of plenty of debate, and I'm sure it'll be something that will arise later on in our proceedings today. The landscape is changing, there's no doubt about that. The lines that developed when we began to use maybe CAD back in the 1980s, where engineers and technicians had differing roles, and has been disrupted over the last while and are less defined. Engineers are now far more involved in the model generation and than they would have been in the 2D past. The skill set of engineers needs to be developed to embrace this technology and to process it. And in our opinion, in our organisation, we're seeing far more involvement of graduate engineers adopting BIM and being able to work and design using that tool, and most importantly in relation to both design and detail and full BIM implementation, working with other members of the design team, but also in relation to analysis and the ability to translate building models over to an analysis tool. An understanding of the implications and resources necessary for proper BIM implementation needs to be appreciated by all stakeholders, and in particular clients. It's appreciated that there are enormous benefits to be offered by the use of BIM. And a well orchestrated BIM project will outlast the construction stage and bring immense value to the client, both at construction stage and also at building use and ongoing maintenance. And for this reason, it needs to be funded by the client. They have an obvious and important role to play in that regard. We've seen time and time again where consultants, and we're probably to blame ourselves, will launch into the execution of a BIM project without fully appreciating exactly what needs to be done and what resources need to be applied to it. But in order for it to be done correctly, it needs to be resourced properly, and it needs to start off on the right foot. And again, that's where standardisation comes into play, in that when people start a project, if they are to start into that without the proper standardisations and common goal, the results will be dissatisfactory. When we first started out using BIM, we quickly found that we had issues in relation to standardisation across the office. And as our input began to develop and move on into wider fields and across other practices, it became very obvious that the standardisation throughout different practices was becoming an issue, and that there was far too many standards out there where people were not necessarily following the same families, the same routes, the same file setups and drafting approaches. And as we've gone further afield and explored international markets, we've again found that this is more and more important in able to deal with our international counterparts and to be able to deliver a properly executed BIM project outside of our own more comfortable neighbourhood, let's say. Let's flick through a couple of slides here of a few different projects that we've done utilising BIM, particularly in relation to conservation projects, which have their own challenges in relation to the design, development and detail, and also from an analysis viewpoint. And the interaction of the old and new structure, again, is something that needs to be properly developed. And again, standardisation in those particular areas can be a little bit difficult to achieve, given human nature and the want and desire of people to draw things and to develop designs based on how they see it. I know I'm running tight on time, so let's move on today. Again, a few demonstrations on current BIM applications. Give you a snapshot of our current involvement on certain projects. And in relation to civil elements, just to note that again, standardisation across the civil side is something that definitely needs to be looked at. We've all developed our standardisation systems in relation to buildings, but we feel that on the civil and structure, on the civil side outside of buildings, there's more challenges in that particular area. One big advantage of the implementation of the standard systems and BIM model is in the analysis software that we've found, particularly across different design houses and software providers. Certainly with the open source and changes in the approach, we're no longer really reliant upon having the one element of software from one company or one design or software developer. It's certainly proven that we were able to change between different software providers, which is a great advantage, I think, and has hoped and has helped, I suppose, to some extent, to allow for software competition to develop and to allow for our design systems to move from one type to another. And certainly the crossover between different softwares and let's say developing a model in one particular software and translating that over to analysis in an analysis software package from a different developer has proven to be more and more seamless as we've gone on. Certainly in the earlier days we found that it was actually quite inflexibility in relation to trying to transfer a model over into a different type of system. And I don't want to get into the names of different software providers, but certainly it's proven to be far more successful lately, and it's one of the main advantages, I think, of the open source and the good development of that approach over the last while. But again, standards have an important part to play in that, and in particular when it comes to detailing our own models, that if we don't start off in the right foot and develop our model appropriately with the right eye on detail, we find that it is not so easy to bring into the model later on, and it involves people building a separate model for analysis, which is a waste of time and completely defeats the purpose of developing the BIM model in the first place. So I hope that we'll see some informative discussion here today, and I know there'll be some points to be made in those particular areas, and look forward to see what's been presented by the following speakers, and to leave here today with a much better understanding and knowledge of where things are at and where the future of BIM lies, and we look forward to applying it day to day in our practice. Thank you very much.